Welcome to aminacademy.com. In complex analysis regarding an overview of complex numbers, let us explain about exponential form of complex number. Form of complex number. We know that a complex number z can be represented by r into cos theta plus I sin theta. And this r is all modulus, r is equal modulus, and tan theta equal y by x. Then argument is theta, that is tan inverse y by x. Now here, if theta, the principal value, of arg z is represented by arg z. Therefore, you can say in general argument arg z, argument of z, general argument of the z is principal value and with integral multiple of 2 n pi, where n equal 0 plus or minus 1 plus or minus 2 plus or minus 3, like it goes. Also, you can say when z is negative, the negative real number, arg z has value. When z is a negative real number, then principal value of argument arg z equal arg z is has the value pi, but not minus pi, not this point. Consider a complex number consider a complex number minus 1 minus I, which lies in third quadrant, since here which lies in third quadrant, because real value also negative, imaginary value also negative, so it is a third quadrant. Suppose this minus 1 minus I, the point P is minus 1, we can get it this z minus 1 minus I. Now principal value argument arg z of minus 1 minus I is minus minus 3 pi by 4. Minus 3 pi by 4 because it is in negative. Both are negative here. It must be emphasized that here the principal value must be the principal value of argz, principal value of argument must be lie between minus pi to plus pi. Therefore, general argument that is arg of minus 1 minus I can be written as minus 3 pi by 4 plus 2n pi. We know that n is equal 0 plus or minus 1 plus or minus 2 like it goes. Or argument of minus 1 minus I equal general argument is minus 3 pi by 4 plus 2n pi. It gets the continuous values regarding the values if you put n equal to 1 plus or minus 1 to 0 like it goes. By Euler's formula, that is e power I theta equal cos theta plus I sin theta. Therefore, from that Euler's formula, that z, any complex number, can be written as r into e power I sin theta, where r equal to modulus and theta is argument. Now that before we get the number, the complex number z is suppose minus 1 minus I. So minus 1 minus I can be equated. Here the modulus of minus 1 minus I is square root of 2. Then that is r exponential. We can write exponential of I into minus 3 pi by 4. Now, in general, we can express this as 1 minus I equal root 2 exponential of I. Here, the principal argument is this one, but in general, you can represent this as minus 3 pi by 4 plus 2n pi, where you know that n equals 0 plus or minus 1 plus or minus 2 like. Here, note this point. You have to remember this e power, the value of e power I pi equal minus 1 and e power minus I pi by 2 equal minus I and e power minus I 4 pi equal 1. We have to remember these values. Now consider z equal r e power I theta is a general form of representation of complex number in exponential form, where theta is into pi. In this, modulus of z, suppose modulus of z equal to r, represent into a circle of center 0 0 and radius r. Now consider this expression z minus z0 equal to r. Once in the that means it's represent also a circle, but is also a circle with fixed vector with vector z0, that means fixed point as a complex number, and a vector of length r, vector of length r, whose angle of inclination is theta. Whose angle of inclination is theta, where theta must be theta equals 0 to theta equal to 2 pi. Now we can represent this in organ diagram like here. Suppose consider a circle here. This center is z0 and this point is r e power I theta. Then we can say this one is z. That means z minus z0, modulus of z minus z0 equal to r can be represented by this. Here this is theta. Now let us discuss further about complex number, product and powers in exponential form. Product and powers in exponential form. Here Consider two complex number z1 equal e power I, no, only first consider e power I theta 1 and e power I theta 2. Now product of this both expression I theta 1 into e power I theta 2 is, first e power theta 1 is cos theta 1 plus I sin theta 1 multiplied with cos theta 2 plus I sin theta 2. Now which is, we can multiply this cos theta 1 cos theta 2, then minus I square is minus 1, that is minus sin theta 1 sin theta 2 plus I is sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. Here we can write further this one. Look at this, cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 can be written as addition of cos theta 1 plus theta 2 plus I sin theta 1 cos theta 2 cos theta 1 sin theta 2 is I sin of theta 1 plus theta 2. So here the product of e power I theta 1 and e power I theta 2 is equal cos of theta 1 plus theta 2 I sin of theta 1 plus theta 2. Now which can be expressed e power I theta 1 plus theta 2. Now thus we can say, now your complex number z1 is r1 e I theta 1 and z2 r2 e I theta 2. Then we can say the product of the complex number z1 and z2 is equal r1 e I theta 1 into r2 e I theta 2, which is equal r1 into r2 e power I theta 1 plus theta 2. This is for product. The same for suppose we can express a reciprocal of z, that is z1 z power minus 1 generally equal 1 over z power 1, which is equal 1. We can express 1 into e power I 0, theta is 0 because anything power 0 is 1. So z is r e power I theta, which is, then we can write 1 by r e power 0 minus theta. Further we can say 1 by r e power minus I theta. Then one more thing, we can for z power n, where n is plus 1 plus or minus 1 plus or minus 2, 1 0 plus or minus 1 plus or minus 2 like, then you can say general r power n e power I n theta. where n is 0 plus or minus 1, like it goes. Now, for example, find the value of root 3 plus 1 power 7. Here, root 3 plus 1 power 7 is equal, here root 3 plus I, not 1, root 3 plus I is a complex number, root 3 plus I is a complex number, power 7. We can express this as, first modulus of root 3 plus 1 is 2, that is here 2 e power I pi by 6, since 1 by root 3 here theta equal to 1 by root 3, that is theta equal to 30 degree, that is pi by 6, and the whole power 7, which is equal to power 7 e power I 7 pi by 6. 7 pi by 6. Further it is expressed, suppose 2 power 6 e power I pi, because 7 pi here we can express 7 pi by 6 equal pi plus pi by 6. So we are using here to 2 power 7 can be expressed 2 power 6 and e power I pi into 2 power 1 e power pi by I pi by 6. So this is 2 power 6 equal 64, but e power I pi is minus 1 into 2 here already that can be expressed, this is, that is root 3 plus I is 2 e power I pi by 6. So we have this one is root 3 plus 1, root 3 plus I. So therefore we can find root 3 plus 1 power 7 is minus 64 into root 3 plus I. Like this we can express any powers of a complex number in this way quickly. Here you know the De Moivre's theorem tells us, De Moivre's theorem De Moivre's formula, better use formula, is cos theta plus I sin theta power n equal cos n theta plus I sin n theta, where n is 0 plus or minus 1 plus or minus 2 plus or minus 2, like the values. Now for example, cos theta plus I sine theta whole squared is expressed as cos 2 theta plus I sine 2 theta. Like any integral powers, we can express like. Or we can say this one, cos 2 theta plus I sine 2 theta can be expressed. Cos 2 theta is cos squared theta minus sine squared theta plus I cos squared theta minus sine squared theta plus I sine 2 theta. Then further you can say cos squared theta minus sine squared theta plus I sine 2 theta is sine theta cos theta. Like this we can express by using de Moivre's theorem of suppose cos theta plus I sine theta power n. For n is any integral power, we can express finally like this expression. Now further information we'll do forthcoming videos. We have done. Please subscribe our YouTube channel.